water, or that it is a universal solvent. More things dissolve in water than any other substance that we know of. Okay? Adhesion. Adhesion is where water molecules stick to other kinds of molecules. Like in a plant, you have the xylem that go from the roots to the leaves, and the water sticks to those tubes as it's going up so that it can travel up against gravity. Okay, cohesion. Co means together. So this is where the water molecules, adhesion means to stick. This is where the water molecules literally stick together. They stick to each other, to other water molecules. All right, high specific heat. It takes a lot for water to heat up. Okay, we talked about that when we talked about the microwave, like you're microwaving stuff and the bowl's really, really hot, but the water inside it is not, okay? Or a swimming pool in the summertime. The swimming pool, the water is not the same temperature as the air outside. It's 105 outside, and the water sometimes it feels freezing cold when you jump in. Okay, that's a good thing, because if the water took on the temperature as the environment outside, then you would have boiled fish all the time for dinner, because all the fish would be boiling, because the oceans would be boiling because it's so hot outside. Okay, so like right now in this room. Okay, so anyway, it takes a lot. Water is very resistant to temperature changes. All right, and then it also has changes in density when it's in its different forms. Like when it's a liquid, it is more dense than when it's a solid, which is actually the opposite of most liquids. All right, but in a liquid form, it expands. That allows it to freeze on top of water rather than sinking to the bottom, because there's a couple of problems with that. If ice sank in the oceans, then that means the water that's remaining would rise, okay, which would mean that everything would either be covered with water, or all the water would be frozen and everything living inside of it would die. It would freeze. Okay, so it is good that it has those properties as well. Okay, we're good with this? Okay, let's keep rolling. Okay, all right, in cohesion, water molecules stick what? Together. You're going to have water molecules sticking to other water molecules. That's the co, means together. Okay, in adhesion, we're adding water molecules to stick to something else. So they stick to other substances. Okay? Water's high heat capacity, this is what we just talked about. It helps stabilize large bodies of water. Okay, so like oceans. And it helps organisms maintain what? Life. Okay, homeostasis is the big word that we're going to use there. And all that means is it's a stable internal environment. It helps your temperature stay regulated, blood pressure stay regulated, and all that. Homeostasis, that word will not be on your test.
No.
Okay? That is fine. That is fine. Okay, what happens to water when it freezes? It expands. Okay? And it is less dense than the water below it. That's why the ice freezes. Why it floats when it freezes. So this causes it to float on top of the water. Okay, all right, let's try to hurry here. Okay, so acids, bases, and pH. When water dissociates or separates, all right, we know that water is made out of H2O, right? There's two hydrogens and an oxygen, okay? When it dissociates or separates, that means it breaks apart into equal numbers of hydrogen ions, okay, and hydroxide. Good. So if you look right here, it's the OH and the H. Okay, it breaks apart into that. All right, so what scale range tells you how acidic or basic something is? pH scale. Little p, big H. Okay, it ranges from 0 to 14. All right, what is a neutral? 7. and our blood pH is about 7, water is about 7. If its pH is greater than 7, it's considered what?
A base.
A base. All right, and what that means is when the water dissociates, it's going to release more hydroxides. So what are 2 examples of bases?
Magnesium and
Okay.
that's what it said in the video.
All right, ammonia, 2 M's.
I'll put
No.
one, but
Is that right?
Yeah, I put 2 in.
Okay.
I just put, yeah.
Okay. So we have things like soap, household cleaners, which usually have ammonia in them. All right, when a substance has a pH of less than 7, it's what? It's an acid. There it goes. Okay. All right, and it releases more hydrogen ions. So a couple of examples of acid are lemon juice and soda. Good. All right. Now, on your test, I will give you some pH levels. So I'll say the pH of blah, blah, blah is 3. Is this an acid or a base?
no,
It's going to be an acid. If it is less than 7, it's an acid. If it's greater than 7, it's a base. Okay? So less than 7 is an acid and greater than 7 is a base. All right, any questions about this part? Okay. All right. The last section was think about it questions. All right. List the following in order from simplest to most complex. Which of these would be simplest? A molecule, an atom, or an element? Anybody know? An atom. Atom's going to be simplest. All right, then what?
molecules.
Element. Element, because then we can join more than one element together and make a molecule. So the largest of these that would include all the others would be molecule. Okay? All right, then it asks you to use the periodic table in the back of the textbook to figure out the number of protons, neutrons, and electrons here. And then the number of electrons in its outer valence shell. All right, for hydrogen, the atomic number is 1. So that tells us that there's 1 proton, there's 1 electron. The atomic mass of that number, of that element, is also 1. So how many neutrons are there? 0. Okay, because you have 1 is the atomic mass, minus 1 is the atomic number. So you have no neutrons. So how many electrons? We only have 1 electron. How many are in its outer valence shell? 1, because that's all it's got. Okay? Now magnesium has an atomic number of 12, and it has an atomic mass of 24. Okay? So how many protons does it have? 12. So how many electrons does it have? 12. All right, my neutrons, I do 24 minus 12, so it has 12. Okay, so on my outer shell, I have 12 electrons. So how many would I have in the first shell? 2. How many would I have in the second shell? 8. But that's only 10. I've got 12. So how many do I have in the last shell? 2 more. So 2 plus 8 is 10. Plus 2 more is 12, and I have 12. So I have 2 in my outer shell. Okay? Does that make sense?
Yep.
All right, you're just filling in your shells until you use up all your electrons. Okay? Now, in nitrogen, my atomic number is 7. My atomic mass is 14. So how many protons do I have? 7. How many electrons then? 7. My neutrons is going to be 14 minus 7.
7.
So it's 7. Okay. So in my outer valence shell, in my first shell, I have how many? 2. All right. How many do I have left over for my second shell?
8.
I only have 7 total.
5.
So if I take 2 away, I got 5. Okay. All right, so I have 5 in my outer shell. Okay, does that make sense? Y'all understand why?
Yep.
Okay. All right. On number 28, as long as you've got this part, you'll be fine. It says draw a diagram of the water molecule. So if you'll draw this just like your little paper model, label the oxygen and the hydrogen atoms, oxygen and hydrogen, and indicate which ones are positive or negative. So these are going to be positive and this is negative. Okay? So that looks just like your little paper model. All right, and if you see a picture of a hydrogen, covalent, and ionic bond, do you think you can recognize it?
Yep.
Okay, covalent, you're sharing on the same shell. Ionic is an IOU. You're donating electrons to another atom. And then hydrogen is typically going to be between water. But remember, in hydrogen, what we learned to remember that one was that if you have a positive attracted to a negative, it makes an H. That's a hydrogen bond. Okay? All right, and then IOU is where you're donating. Okay, and ionic bonds, IOU, and then covalent, co is together. All right, bye guys, study.